Murthy garu, good morning, sir.
Namaskaram, Rao garu. Now, our good friend Dr. Bharti is there now for us.
Yes, sir. Yes, sir. Thank you very much for connecting us with him. So that,
Always.
right.
Always for D.N. Raoji.
Right, sir. Dr. Bharti, sir. Good morning, sir.
Is he there?
Bharti, sir.
Yeah, he is connected, sir. He is connected, but he is muted.
There, yes.
Good morning, all of you.
Good
And this
morning,
week-
Dr. Bharti, sir. Good morning.
Good morning, Murthy sir.
Good morning. Good morning.
Yes, yes. And Murthy sir is on board, sir. I am D.N. Rao. I am the co-promoter and trustee
Right,
also,
introduce.
and vice president. And yes, Pushpa is also there. Right.
Dr. Bharti, sir, thank you so much for this, your presence today. And Dr. D.N. Raoji is the driving force and a wonderful person in the country. And I'm very happy to be associated as a good friend for him. And Dr. Bharti is a nationally and internationally renowned biotechnologist and the CMD of Gromore Limited.
Thank you, sir. Thank you for your appreciation.
Yeah.
Yeah, we are very, very honored, sir, to have you, Dr. Bharti, sir.
My pleasure. My pleasure.
And we have a decent, size biotechnology team, almost 7 professors in
Okay.
biotechnology, because we have a school of agriculture, sir, named after M.S. Swaminathan, sir.
Yes, I saw that. Yes, I know.
Yes,
Yeah.
it's ICAR accredited, second private university in country to be accredited by ICAR.
Okay.
Right. We are also running MSc-AG. In the MSc-AG, we have also got plant breeding and genetics as a program.
Okay.
And we also have set up now very recently nanopore sequencer for even genomics and genetics.
Excellent. Excellent.
So we have also another 7-8 people working in genetics area. We have a Bhubaneswar campus also. We have 3 main campuses: Vijayanagaram, Parlakmadi, and Bhubaneswar.
Okay.
Our vision is actually like Century University, sir, is more interested in not just teaching but also production.
Okay.
You'll be, in fact, we have more than, that's how Murthy sir is on our board, and we have more than 50 industry labs.
Okay.
When I say industry labs, they're all sponsored by industry, where the equipment are given by industry, sir.
I see.
We have received more than 150 crore worth of equipment from various companies in India. So we work very, very closely with industry.
Very good.
So,
very good.
And we have a partnership with Bosch, we have a partnership with Dassault Systems, we have a partnership with Ashok Leyland. Almost all automotive 2-wheeler, 4-wheeler companies, they have their labs on our campus. Eicher, Volvo, Ashok Leyland and all. Even in tissue culture, our vision is to have production facilities on campus. So today we do about 20 crores worth of production of various things like machine parts, auto parts.
Okay.
Then we do apparel. We have a very big garment factory of 1,000 machines in our campus. We have a wood manufacturing unit on campus.
Okay.
We do e-rickshaws, electric vehicles also. We do e-rickshaws and we sell them.
Okay.
Right? We have 4 gram tarang companies, sir, which are into skill development, financial inclusion. We have a fintech company also, so which have a combined turnover about 150 crores.
Wow.
Right? And so our vision is to actually also get into, we also believe that academics should get into production, sir.
Okay.
And students also should be, soiling their hands on production and not just labs.
Okay.
So we are actually setting up a 10 lakh plant. We have a small lab in Parlakmadi where we are doing 1 lakh plants. It's not running that successfully well. So we now shifted into Vijayanagaram.
Okay.
And we have set up a 6,000 square feet facility where we will do about, planning to do about 10 lakh plants a year. That's our capacity kind of thing we are planning. And that's when I was talking to Murthy sir about some kind of a support. We are actually doing presently Gerbera cultivation. We are, as part of the course, under Polyhouse, sir. Under Polyhouse, we are doing Gerberas.
Okay.
Right. Okay. So we also want to promote floriculture being near to Vizag. Right. Okay. In a big way. Right. Okay. So we also work very closely with Andhra government and Odisha government, very, very, very closely. I'm in the advisory board of Andhra government for skills also.
Okay.
So I just want to give you that background to this, and we're very, very extremely happy to have you. But actually, but for this lockdown, I would have chased you in Bangalore itself, would have come and met you. And
My pleasure,
right.
sir. No,
So
we
we would need your help and blessings, sir.
Sure, sir.
And our agriculture
So
school will be
let's work together
honored.
to see something happens in the ground. Science should
Yes.
reach the ground. That's all.
Yes. Sir. So Pushpa is our lead anchor for this program. She's incidentally from Bangalore only. She's a Kannadiga.
Okay.
Pushpa Ganeshan she is, and she's based now the campus, and she's the one who's driving this tissue culture program, and she's been with us for last 10 years now.
Okay.
Right? And we have Dr. Renuka from
Yes.
Bhubaneswar, and who was actually in genomics and all. Grow Lakshmi, quite a lot of people. Sir, Grow Lakshmi did a PhD from University of Texas, College Station. So there's quite a decent talent. There's one Dr. Pradeep who has actually worked in Canada and come back. There's one Dr. Preeta who's quite good in biotechnology, and who's actually also working. We also have a CO2 extraction plant, sir, where we do a lot of oleoresins and spice oils. That's called Gram Trunk Foods. Yes, we do about 3 crores worth of business every year.
Okay.
We are now working with Natural Spice Board in developing, organic cosmetic products.
Okay.
We are actually,
Okay.
So this is a brief background, sir, but I would not like to take too much of time. I think everybody is waiting to listen to you. So over to Pushpa.
Thank you so much, sir. I was thinking formally I'll start and hand it over to DN, sir. But
let no formalities. You give sir the mic so that he will start dazzling us with, right?
Yes. Thank you, sir. Thank you so much.
Yeah.
Good morning, each and everybody who is attending the webinar today. On behalf of the department and the institution, I offer my greetings to our Vice President, Sir Professor D.N. Rao, Dean Dr. S.P. Nanda, and Moti sir has joined now, and I have gratitude to Moti sir, and all the departmental faculty members and all other faculty members who are present over here today. I convey my regards to chief guest of the day, Dr. N. Bharti. Sir, thank you so much for accepting our invitation and coming over online for the webinar. The scheduled webinar will focus on the topic of interventions of biotechnology in agriculture. The theme would be in vitro micropropagation of commercially important crops like bamboo, banana, sugarcane, jabara, etc. I wish this webinar will enlighten all of us, provide us the approaches that we deal with the problems associated with plant tissue culture and its commercial aspects. So in this view, I welcome Bharti sir again, and just give a very quick introduction about him. He was a agriculture scientist from Tamil Nadu Agriculture University. He was the first tissue culture researcher for PhD in 1981, and he worked as assistant professor from 84 to 85 and moved on to this commercial industry of tissue culture, established around tissue culture laboratories of a size 10 to 200 lakhs per annum. So that's a big one for all of us who are listening today. And after working in corporate companies, Dr. Bharti promoted this Growmore Biotech Limited for the production of 85 different species of plants by tissue culture process. And he has included all agriculture crops, horticulture crops, and herbal plants in that. Then he exports this Growmore Biotech exports this plants to 30 different countries. I have briefed this information in the mail that I have circulated internally. Dr. N. Bharti served as a planning commission member in the subcommittee on high-tech horticulture and later on renewable energy also. Currently, Sir is the lead for this Growmore Biotech Limited and producing about 10 million plants of bamboo and establishing energy plantation based on Bima bamboo for the generation of electricity and other production like bioethanol, petrol, diesel, etc. So with this introduction, I would request Dr. Bharti sir to kindly take over the field and address gathering. Thank you, sir.
Thank you very much, Dr. Pushpalata,
Thank you, sir.
Dr. Rao, Mr. Murthy sir, who was instrumental in bringing me to all of you here. Thank you very much. Yes, sir. It's nice to get back to the students, talk to them. I did my research 45 years back. I started 45 years back in tissue in research, and 40 years of work in tissue culture. That made me little more refined in biotechnology, especially in the tissue culture. And the journey, what I did is I just changed the techniques, the research techniques, into a technology. I mean, technology is large scale production. We all doing, my mother and my wife does a cooking in the house in a smaller way. Somebody wants to go do a cooking in a marriage party, it's huge number. Similarly, when you want to do in a large scale production, the informations, the system to work, all are very different. We need to work with different, type of people and different levels of chemicals and instruments, equipments, though basically they all same. So what I did in the last 40 years, I've been commercializing the regular technique, tissue culture technique into a technology where I reached a level of 1 lakh production every day. It's a long journey. When I was like you, student, I used to do 120 plants. I used to feel very proud because my co-workers or my professors or the teachers who were teaching me tissue culture in 1980s, they used to do only something like, 80 plants, 60 plants, but I used to do 120 plants. I used to feel very proud in a day. But when I went to UK, it's around 1984, I saw people making 800 plants in one day. I was surprised. I said, it's not possible. Then I sat, I looked at them, I looked at everything, the movement of the hand, the time motion study, how they're doing it, and then came back to India, started working with our own people. Then that has landed in a number today, 4,000 plants by an operator every day. That's a big jump for me. Today, all people who are doing, they are not that qualified like me. They are all simple education, but then they are skilled. And that made me to do a 1 lakh plant with just 40 people working in the laminar flow chamber, 250 people working for all the operations put together. And I unknowingly, I become the largest bamboo tissue culture lab in the world. Why bamboo? Because one is the technique of doing it, another is where is the market, where is the volume, who wants more plant, which is the industry needs it, which agriculture can improve this one. That's what I was looking at it. I'm going to talk to you more onto the different types of plants I worked on 85 different species. I started with rice, went on to cardamom. In 85, cardamom tissue culture developed through DBT and planted in the field. Then went on to a banana, then to a lot of ornamental plant like lily, gerbera, carnation, and then ficus, cordyline. That is foliage plant, flowering plant. Then went on to herbal plant like patchouli, then pepper, ginger, turmeric, various types of plants. Then finally I landed in tree crops like eucalyptus, Casuarina jingoniana. Then I happened to touch bamboo also as a 85th plant in the year 2000, 2001. Then I realized we are sitting in a gold mine, bamboo, which we never explored. And then I took this technology of tissue culture to increase the national yield of 0.5 tons per acre to 40 tons per acre. For me itself, it was unbelievable number, right? That's how it's all started. Let me get into some of the details. the presentation to show you. And I take my screen. One moment, I'm just, yeah, I located. Are you able to see my screen now?
Yes, sir.
Yes, sir.
Yeah, thank you. Thank you. You know, this is the commercial lab, large-scale tissue culture lab, where you photocopy the plant. One plant into millions of plants, 10 lakh, 20 lakh, 100 lakh, 200 lakh plants. And today we'll be talking on the intervention of biotechnology in agriculture, how it can do that, how it can improve the yield, how it can improve the quality, how it can increase the production. And that's what we're going to do. I'm very happy to associate with the Department of Biotechnology as webinar in this today event of 28th June. I'm Dr. Bharati. I did my PhD in agriculture and then way back. And then I'm very happy to be one of the speakers for the Centurion University today. Look at the banana. These are the banana which we developed 24 years back, and they are uniform, bunching at the same time, uniform bunches coming into one side. And all this, when I was doing it in 85, 86, people laughed at me. I said, how come tissue culture can do it? We are getting a sucker, banana sucker, which is a kilogram, 2 kilogram sucker, you plant it, you're getting it. Whereas a tissue culture plant, tiny ones, 20 grams. Maximum it could be around 300 grams. And the plants are looking very puny, but they are vigorous, they are free from diseases, they are free from virus, and they're genetically pure. All that was not known to them at that time. When you plant them, when the farmers grown it, these are how the farmers are very well to get the bamboo. And those yields are extremely high. People used to get around 20 kilogram, 25 kilogram bunches those days. And I could show the bunches of 35 kilogram, 40 kilogram bunches. You look at them, cylindrical bunches uniform. So all these are agriculture requirement for which tissue culture was able to provide the same kind of a planting material. And they were not able to get enough number of red bananas. Very expensive banana in the market. Very expensive. They are 3 times more costly than that. Tissue culture through which we could produce and give it to them, and look at them so shiny, uniform, and not less than 13, 14 fruits in a hand. All these could be made through tissue culture. Not only that, we could introduce new varieties, and bamboo could produce uniform maturity. Bamboo tissue culture could produce high yield, and they could provide disease-free planting material of such super material. And we introduced the first variety called Madhukar. Madhukar was one plant was found out by a farmer in somewhere in Gujarat, and it was brought and given to me. And from there, it was multiplied to a large number. Tissue culture could be one of the tools to increase the productivity of the field through multiple propagation. And look at the Madhukar bunch. When it went to the exhibition, they won the first prize because they had so much big bunch. Look at them, it's almost to his chest, it is there. That's a type of bunch. People couldn't lift it. It is more than 60 kilogram bunches are there, and that is how it is there. It is not, the story doesn't end with one crop. I told you 80 different species. Look at the sugarcane varieties, different colors, different taste, different content of sugar, and different content of fiber. Sugar industry needs fiber is needed for cogeneration, and sugar is needed for making sugar and ethanol. And like this, for everything we need it. And this are all the set of tissue culture plants developed through tissue culture from sugarcane, and demonstrated in the year 1985 itself. And today it's become a tool for many people. It comes as a seed. The story doesn't end with sugarcane and a banana. I told you vanilla. Vanilla as a plant does not produce seed. But then the price of vanilla went up to so high that 1 acre of farmer could earn 50 lakh rupee. from 1 acre. And that was a boon, something like around 15, 20 years back it had happened. Madagascar was full of vanilla. When that vanilla got affected for disease, automatically people started looking at other sources. India became one of the best sources, and the planting material was not available. So tissue culture became a handy tool to multiply these kind of orchids into a large number and made it available. I was one of the person who supported the entire project for them. A new plant today, take 10%, 2 to 3% are diabetic. What do you mean by diabetic? You can't eat sugar. You can't eat sugary substance, tasty material. But that's very essential. Even for a birthday, for a exam, good marks, you just try to distribute the sweet. But those sweets are not eligible more than 25% of people in India, because India is a capital for diabetic in the world. Now there is a plant called stevia, a sugar-free herb, was available only in South America. I brought it 20 years back, multiplied through tissue culture, looked at for some other variant which can grow in Indian condition, and then this was available. This is sweet. How many times? 20 to 25 times sweeter than cane sugar. That's the beauty of this. And from there, it went on for cultivation, large-scale cultivation, and went on for large-scale cultivation. Then monocrop detached. Then we went for tree crops, casuarina, a fast-growing casuarina, no seed, sterile, and look at the diameter. In a matter of 4 to 5 years time, it could come to this diameter. And this plant came from Thailand, being sterile, no seed propagation. Only 25 trees were there in a place called Marakanam in the Pondicherry ashram. And that was taken, tissue cultured, and made available again for a cultivation large scale. Like this, we kept on taking the best plant in the nature or bred material by a breeder, and then tissue culture became a tool to propagate it. Similarly, I work with the Paulonia, a fastest growing tree. It comes to this height in 10 years' time. And it gives you 1 cubic meter of wood per tree in a matter of 10 years. And this Paulonia tree originally from China. From there, it went to Australia, went to America, and so many places. So we got the right clone from there, which is suitable for Indian condition, brought it to India, faster multiplying through tissue culture, and tissue culture make it available for large scale. Bamboo. The most fastest growing plant in the earth is bamboo. 1.5 feet a day. 1.5 feet a day, not inches. And that was the bamboo, and this bamboo is called Dendrochalamus giganteus. When I went inside, there are more than 1,300 species of bamboo with multiple uses. I looked at India. What is the agriculture improvement it can do? So when I looked at India, India has got 13.9 million hectare of bamboo. It's like this in the wild in the forest, and with a yield of 0.5 tons. That means 1 ton only is coming now from one hectare of bamboo. 12.5 million tons of bamboo is coming from 13.9 million hectare of bamboo. Less than 1 ton. Less than 0.4 tons per acre. This is the national yield of bamboo. Then went on working for breeding. So I went on to different farmers' field, kept on surveying, and then I found out farmers' field like this, which are able to make 4 to 8 tons per acre. I was a little satisfied. I said, okay, oh my God, we're not very bad, we're better. Then I applied the breeding technique. I did my PhD in breeding, genetics and plant breeding in agriculture. So we applied on this. We did only a pure line selection from open pollinated half seed population, analyzed for the variant, picked up the best plant, named it as Bima bamboo, and the precision farming is applied. It became 40 tons. Oh my God, 0.5 tons to become 40 tons. Now this opened up the market. Till then, till this 0.5 tons or 4 tons, it's only for a handicraft, for a house construction, for furniture making, very small volume bamboo. when we could make it into a higher productivity agriculture through tissue culture, we brought in a different purpose for bamboo. We produce electricity from bamboo, produce ethanol from bamboo, produce petrol and diesel from bamboo, CNG gas from bamboo. We are working for hydrogen from bamboo. Now, Reliance is opening up in a very big way to make this renewable energy, including hydrogen. And they also may not know that the bamboo can give this kind of inputs. And this is such a wonderful plan. But tissue culture is a one. Help me to see that this has become a crop of high yield, like a sugar cane. Sugar cane also gives you 40 tons per acre, but it's a wet weight. Here, 40 tons per acre is a dry weight. Excellent carbon sequestration. You know why? Because they grow 1.5 feet a day. And now let me come back to our original topic, micropropagation, tissue culture. Tissue culture, there are various applications of tissue culture. It could be for protoplast, it could be for somatic hybrids making, or it could be for genetic engineering. After that, when you get a cell, convert them to plant, all that is possible. But let's look at micropropagation. It's a simple cloning of pedigree plant, making multiple true copy of the original pedigree plant. When you want to go buy a dog, we ask for a pedigree. But we don't do that for a plant, especially for the trees which are going to remain for long, many years. Today, when you buy a coconut seedling, you simply go buy it. You do not know what is the yield. You'll come to know only after 5-6 years. The reason is we don't have a pedigree plant. We have hybrids, but the hybrids are not uniform. A tissue culture coconut is going to be uniform, but a conventionally crossed one will have some amount of residual segregation, genetic segregation, which will lead to some amount of variability. It's not like a pen what you're buying it. It's not like a laptop what you're using today, or like not like a cell phone. All cell phone of that particular company, a particular brand, same. That's what the tissue culture is going to offer you. And this, once it is introduced in agriculture, that is the way the agriculture can increase the yield. How do you do that? You just take the best mother plant, take a small meristematic region of the plant, put it in a test tube, and you sterilize it. After that, put in a test tube, then multiply them, proliferating them into 1 into 1,000, 10,000, or 1 lakh, 2 lakh, 10 lakh plants. Then you root them finally, take it to the hardening chamber, greenhouse. Then you put them in the nursery for a couple of months and give it to the field. The entire process in a banana is over in a matter of 12 months. In bamboo, it takes 1 year, 2 years, 24 months it takes. Minimum 21 to 24 months, depending on the plant. If you go to the date palm, oil palm, all that will take 3 to 4 years time, because it has to go through a somatic angiogenesis, and from there you multiply it, then harden them, then you give it. And when it comes to sandalwood tree, you need not only the lab, you need to put a host plant, then host plant should join together, then it is delivered. Right. The first stage of any such tissue culture process is mother plant collection. You should have the best mother plant. I'm just showing with the examples of the bamboo. This is one of the bamboo called Bambusa bulkova, from where the variety Bhima was developed. Taken to the laboratory. Laboratory is cleaner than open heart surgery theater. Yes. Clean, very clean. Now, there is no virus. They did not put any mask there. And the filter, Ih2 filter, takes care of it. 24 hours is going to pump the air, which is filtered for bacteria, fungus, and virus. And that's a place the plant is taken, sterilized. And the lab looks like this. The commercial lab, large-scale lab looks like it, completely sterile. And it is kept in a growing room like this, with the artificial tube lights. And the light is given for 12 hours, 14 hours, depending on the plant species. And the temperature is maintained there. There, you keep the first small tissue in a test tube. Small tissue. Sterilize it, make it free from all bacteria, fungus, and then you put it, otherwise bacteria will start growing as a contamination. Now, after you put that, they start germinating. It takes 3 to 4 weeks to germinate into a plant without any roots. The hormones and the chemical, the nutrients which are there, able to push them, produce them, make them to produce this. Then from there, graduate it to the bottle, where the clump size become bigger in 2 to 3, 4 months time. So till the clumps become multiple shoots, 25 shoots a year in this one bottle. Till that time it is kept in a single shoot, then it is increased for multiplication stage. This is the original clump, and it is dissected in the laminar flow chamber. And after chamber is dissected, they look like this every time, grows like this. Divide them into smaller one and plant it. When you in the multiplication stage, you see them, there is no roots are developed, or root developing hormones are not substituted in the media. Only the cytokinin which are going to accelerate the multiplication is given. So one plant become 3 to 5 plants, and then 5 will become 25, 25 will become 125. It keeps on increasing in a matter of 6 months to 8 months. It will become few lakh plants, could be 5 to 10 lakh plants. So one tissue will become 5 to 10 lakh without any roots. And all these are done in a continuous chamber like this, where people are growing 100,000 plants in a day. And then it is kept in every time when you do the production subculture, it is put back to the growth room to grow like this. These are all in a mobile rack system where it moves so that you get a lot of space inside. All these are development which I brought into the lab long time back. That's how the multiplying culture of bamboo looks like. I don't stop with this. I also innovate quite a few things. I'm not a normal biotechnologist, a normal tissue culture man. I'm the first person using sunlight in the growth room, not in the greenhouse, in the growth room. This is my innovations. I've developed this around 20 years back. Using it is comfortably, reduce my cost of electricity. If I have time in the end, I will show you more onto this. This is the normal growth room. This is the sunlight growth room. No tube lights. Only sunlight comes from the top. But the rooms are clean, sterile, everything is sterile. Similarly, I developed not the bottle alone. I am the first person introduced bottle in 1985 to tissue culture industry in India. Till then, I was also working with the conical flask and test tubes. Then I kept on working. I said, why should you use bottle? These are the boxes where cap is equal to the bottom. In a bottle, the top is less, the bottom is more. The bottle is big, the cap is small. You're equal size. This gives an advantage for me to articulate. This gives an advantage for the plant. Different height of the plant. I change the cap of 1 centimeter, 5 centimeter. Even if I want, I can put even 15 centimeter cap. So the base remains same. So autoclaving is for the base. And this is how the plant looks like. All these are different engineering innovations. I'll tell you, engineering innovations. You are a university where you have a lot of faculties, not only biotechnology, you're also into so many engineering, mechanical, and electrical, all that can play a major role. My passionate subject is engineering. That's one of the reasons why I could do quite a lot of innovations in tissue culture, even in bamboo also, and that made me more successful. Less cost of production. My electricity bill, because of the sunlight room, from 10 lakh rupees per month, it has come to 1 lakh rupee. Huge difference. That saves me a lot of money, and I'm able to go compete with them. This is our laboratory where the media is prepared, and it is put in a big autoclave, a double door autoclave where media is loaded from this side, sterilized and taken into the sterile room directly. It doesn't come back to the dirty room again. And these are all the bottles. 1, 2, 3, 4, 5 layers of bottles are kept here, and the entire thing is loaded into the autoclave and they get sterilized. And the second door, double door autoclave, the second door opens into the sterile room, opens up, and it's removed from there. Okay, let's come to the rooting stage of the plant. What do we do for the rooting? Rooting, you remove the plants, the clumps, into smaller ones, small ones cut like this, and then it is put in a rooting media. Then so far roots were not there. Now you can see them, the roots started coming out one by one. And then in a matter of 4 weeks, all the plant will have enough roots. The root shoot ratio is balanced and the plants are ready to go to the greenhouse. And while doing that, if you make mistakes, they do also behave differently. You can see them. The root has come, the plant has died. Operation success, patient died. Partly died. Here, roots has come, shoots have come. So one has to really look at what are the media needed, what is the condition, what is the dissection technique is most important, and which varies from plant to plant, species to species. Within bamboo, one species is different from another bamboo species. Now, after that, it has to go for hardening. Hardening is done in a poly house where natural light is there and the natural temperature, and it's got a fan on one side, so it's able to remove the heat through the wet pad system, and the plants are looking like this. These are all sugarcane plants. Sugarcane plants getting hardened, and people are working for it. And this is a plant called prunus. This prunus plant, it was sent to Germany. By the way, I've been exporting plants for the last 40 years to different countries throughout the world. I would have exported not less than 50, 60 countries so far. Name it. I've been exporting to Japan, Australia, New Zealand, Indonesia, Philippines, Malaysia, Singapore, all this side, similarly other side, to all Arab countries, African country, America, South America. You just name those countries. Every place we are sending it from India, and that is the potential of this. This is banana plant, banana fruit tree, and this is a bamboo getting hardened. Most difficult plant to get hardened is a bamboo, not the banana. And then they look like this in a matter of 2 weeks. And if a condition is dry, if the condition is very dry weather, based on the weather, your greenhouse size and the multiple tunnels should be there. This is the bench. On the bench is covered with the polythene sheets, and inside the bamboos are kept. And after you put the bamboo or those plants, the bottom will have a gunny material, so that to increase the humidity naturally also, and is covered. Now, I also worked on, do we need such big greenhouses, or can we make a simple ice cream cup with a water cup into a greenhouse? That's my this is what I did around 10 years back. I was very successful, but this is okay for a smaller laboratory, but not a very big commercial lab where we are planting more than around 30, 40,000 plants every day. Very difficult. But however, we tried for large scale. That's how you look like. The bottom is an ice cream cup. The top is a water drinking cup. Both put together, clean film is placed, plant is kept. As a miniature greenhouse. You don't need a greenhouse for this. Yeah, that's the idea. Can we reduce it? And a tray it was kept, and plants are able to get hardened beautifully. And the cost was high. You can see them how the plant looks like after the cup is removed. After 4 weeks of time, the plants are hardened very well. You can see them how they are growing nicely here. This is around 5 to 6 plants are growing together, and then it is transferred to them for that. So this small cup is to replace the big greenhouse. That's what the idea is. So I've been doing a lot of practical research like this, but then for a large scale, we need to do this way, which is a very high one. These are the tiny small bamboo plants ready for after hardening. This is what I'm exporting throughout the world. Whenever I'm sending it with the plastic net pot, where the roots coil here and the plant shoots are grown fully and fully hardened plant, this is what being packed in a box, and it is sent like this. It is all plant in a box, and you can see the closer look at the bamboo plants and the fully coiled root system. Either it could be net pot, plastic pot. Some countries say, no, I don't want to have any plastics. Then we all do a natural coiling over the roots, and the root is fully coiled like this. Then that's what it has been sent to them. Then it is grown on a poly bag to grow to this size. It takes 3 months. How? It is done like this. Initially, you keep the poly bag ready and fill with the media. Once a plant comes, you plant them here. 1, 2, 3, 4, 5, almost 10 plants are kept here, and this one bed. After 2 weeks time, it like this. After 2 months time, it will be like this. I can show you this one after the other, how the bamboo plant is able to grow. While when you do this, you need only a shade net house, not a poly house. And the soil should not be a soil, should be, should be sand. Should be material which can reduce, allow the water to drain. No water should stagnate. And then the plant grows like this. And grown-up plants are packed in a truck vehicle like this and sent. In the beginning, I used to put only one layer, and it is very expensive. One lorry can take hardly something like around 5,000-6,000 plants. Today, After working for this 20 years of time with the bamboo, now we know one about the other. This is a second layer, then we put a third layer, then we put a fourth layer, then we put a fifth layer. So it is able to take 35 to 40,000 plants. The plants are loaded like this continuously into the lorry and sent to a various distance. From Bangalore, the plant is going up to Punjab, going up to Uttar Pradesh, Orissa, Maharashtra, Gujarat, and if somebody wants from Northeast, like Mizoram, we are sending 1 lakh plant every month. Or if it is to Bhutan, we airlift the plant. For a longer distance, a smaller plant. The first stage is airlifted. So bamboo should be looked at, and what is this one is to do, what stage is to be done. Okay. When you take the bamboo to the field, when you plant them, they grow so fast. You look at this plant, the person who's standing there, the plant height is so much. And this is the field, uniform growth of the plant, and bamboo is grown like a sugar cane. Now, tissue culture improved the agriculture and brought in agriculture into bamboo cultivation, which was not there at all. So a regular bamboo plant produces an income of yield of 4 to 6 tons, whereas tissue culture plants are able to make 40 tons. Net income of 10,000 rupees per acre. Here, tissue culture plants are able to give 1 lakh rupee per acre every year. I know Orissa is full of rice. I did my PhD in rice. If you get more than 7,000, 10,000 rupees per acre, it's excellent money. I found out in the last 40 years, bamboo can give you 10 acres of rice income from 1 acre of bamboo. And 1 acre of rice water is sufficient for 5 acre of bamboo. So that is a place you should combine biotech with the crop, with the agriculture, then the innovation is there. If you just simply do tissue culture, I don't think it is going to have any good application. That's what I found out over a period of time. And today, tissue culture is able to give purity in the variety. And it's able to give you the disease-free plant. And it is able to give high growth rate. Growth rate is superb. It's not like rhizome plant. And these plants don't have thorns. A thorny plant attracts snakes, difficult to harvest. So now tissue culture plants are thornless and they have highest yield of 40 tons is what average farmer gets it. The potential is 100 tons per acre per year. Now I'll just show you some of the plants which I did around 20 years back when I started my first tissue culture bamboo. You see them, this is the first bamboo which I planted. Small and not much growth difference. Then in 6 months' time, look at the same plant shoot up. And another 15 days' time, you look at this, the shoots have come out so well. The new shoot is coming now. The branches have come, the new shoots have come. They keep growing like this, and you see them in 1.5 years' time. They are so big, the boy is standing. This is a casuarina tissue culture, the bamboo tissue culture, planted at the same time. Look at the difference between these two plants. Both are vigorous. Compared to other casuarina, this tissue culture casuarina is superb, but in front of bamboo, nothing. And you see them, this plant, how many shoots have come? And bamboo today has become a commercial crop, like a sugarcane crop, and it is growing like this. It's a line crop. Why? Because uniformity. Why? Because you are able to get so many species of same type of plant through tissue culture, and the agronomy is developed today for bamboo, which was not there so far. Knowingly, unknowingly, the custodian of bamboo so far was Forest Department, which was looking only for conservation, not cultivation. Agriculture college like yours is the one which is needed to work on this. But unfortunately, throughout India or the world, nobody is really worked on this for agronomy. I spend my own money, time, other than tissue culture, and standardizing this technology of growing them to get 40, 50, 60 tons of bamboo per acre, dry bamboo per acre. Okay, let's come to the tissue culture. What all plants can do? As ma'am said in the beginning, there are so many ornamental plants are there. And when I say ornamental, syngonium is one. foliage plant. Limonium flowering plant is tissue culture, and which was not there. Today, a lot of people are doing it. I was the first to introduce way back, 25 years back. Kela lily, a New Zealand flower, which was introduced in India by myself around 25 years back. Ferns, tissue culture, Dracaena, ficus, orchids, waxflower, caladium, dieffenbachia, orchids, anthurium. Then the foliage plant like Calathea, very expensive. Each plant is 500 rupees. Marigold flowers. Marigold for flower as well as marigold flower taking pigments. Then the nice little plant like Venus flytrap to catch the mosquitoes and fly and other things. Of course, rose, everybody knows about it. And the spathiphyllum, peace lily, alpinia. These are all some of the few list of plants in which I worked, successfully exported to several foreign countries. And their list is exhaustive. I cannot give completely. It is much more than this. Let's look at the commercial crop, what is possible through tissue culture. Potato. Seed potatoes are there, but potato through tissue culture is able to make the plants virus-free. Tomato. Yeah, there are tomatoes are giving 25 kilograms per plant. And they do the grafting in Holland. And that could be done through tissue culture. Similarly, asparagus. Asparagus is a male and female plant. Male produces more number of shoots. Female produces less number of shoots. So when you go through a normal plant, you do not know which is male, which is female. Like papaya, you won't know that. Now, one can take only male or super males available, and that super male you can take it, multiply and give it. Similarly, it could be turmeric, it is ginger, all these we have done it, and I provided the plant. After all my experience telling you, these are all the good commercial crop available. When it comes to fruit, no doubt, banana is the one which has become a very big plant. In 1985, when I started banana, people never used to buy it. They were able to look at a tissue culture banana because I used to sell at 5 rupees a banana, whereas it is free in their backyard. Today, at 15 rupees, everybody is going for replanting a banana with the new plants, tissue culture plants, they are doing it. Well, at that time, to sell 1,000 plants, I used to find so difficult. Today, more than 500 lakh plants are sold throughout India. So many laboratories. I'm there in Hosur. Here itself, I find more than 40 laboratories are working in banana. When I started in 1991, not even one lab. Mine was the first lab. Today, looking at the success, a lot of small labs have come. They are able to make 40 laboratories here. And similarly, I told you, I've shown you the plant prunus, pomegranate. There are many new varieties of pomegranates available. Ganesh is there, and Arka is there. So many new varieties are there. So all these could be easily propagated, made available, virus-free. I did it and I exported to South Africa. Similarly, pineapple, strawberry, even watermelon, seedless watermelon. A cross between a diploid and a tetraploid will give you a triploid. A triploid is seedless. Today, in the market, not available because every time you have to cross, success rate is very low. But in tissue culture, one watermelon can get multiplied into millions of watermelon, several lakhs. What is needed is a large laboratories to do it in a low cost. Then it is possible to do it in a large way. Similarly, medicinal plants, medicinal aromatic plants, patchouli, aloe vera, geranium, safed musli, rosemary, pepper. Sirigurinyan is Geminima silvestri, Gloriosa superba, curry leaf. I can keep on giving you the list there, but we have to connect with the industry which is going to use it. In aloe vera, for example, in aloe vera, I work with aloe vera to producing a plant which is olivine free, which means it is bitterless. It can produce gel without any bitterness. You can just take it like a cucumber. You can eat the aloe vera. That aloe vera I found out from one of the Vaidyas. One of the person who was giving me the local medicine, and he said his forefather has got this one plant and he's keeping it. It's a mutant, but through tissue culture we could multiply them into several thousands and give it to people. So aloe vera, when they want to use it, the gel, they remove olivine and then they use it. Whereas this aloe vera can directly get used. Similarly, Pacholi. Pacholi plant in Indonesia is quite a common plant with a higher node, better node, better small. So one of the gentlemen who brought to me this plant and then asked me to multiply, and it was grown as a crop below the coconut tree. I can keep on sell stories after stories after story for every plant. The Gymnema sylvestri, Siligorinjan, it's for a diabetic plant. It's got a gymnemic acid. And normal gymnemic acid is around 1 to 2% or 3%. But there are plants found in the nature which have got up to 12%, which means one leaf is sufficient for a normal leaf is sufficient. Gymnema high concentration leaf sufficient for 5 to 6 leaves of the other normal leaves. So the concentration is very high. What Ayurvedic company wants to have such high concentrated gymnemic acid so that they can buy only less raw material to make the tablets. All these are needed for every industry. So if the moment you connect with the industry, any crop has got a potential. It's not only the bamboo, but bamboo, I took it up very seriously. And today I'm connecting with people who are producing petrol. Shell companies making petrol and diesel out of bamboo. Yes. Similarly, there is another agro gas company in Pune is able to convert into a CNG gas. Similarly, there are Indian science could check up and say bamboo, 1 kilo bamboo can produce 1 kilowatt current. So the three crops when you come, casuarina, bamboo and paulownia. These are the crop in which I've worked and I found a good success, and the bamboo I continue to large scale. This is what I said, bamboo can give you very good yield and higher yield. So bamboo is the next disruptive technology to dominate the future. Do you understand what I'm saying? Bamboo is going to take away the present technologies of so many things. This will become a raw material for that. Like, if I tell you Patanjali has come and it has taken over most of the shops. Uber taxi has come, all the other, including auto rickshaws, started reducing. Let's look at the phone. The phone is totally gone. This phone is so common when I was very young. Today, we see only the cell phone. This is how this called disruptive technology is able to remove one, completely dominate by the one. Amazon, when it got introduced, we thought who will buy a material by touching and feeling? You will not buy it. Today, everything is sold. Shoes, watches, saris, shirts, pants. All these are sold and everything is coming through Amazon. And not only Amazon, there are many other people are doing it. So that way, bamboo is going to be a distributed technology the moment you improve the agriculture through biotechnology. Otherwise, bamboo is a bamboo. Bamboo is there in the world for last 1 million years. In the fossil also, bamboo is bamboo. Cockroach is cockroach. Human beings are not human beings. We have been evolving. We have been evolving from the monkey. We could see the trace, but not bamboo. Bamboo evolution is over a long time back. That means it's one of the highly stable plant in the planet. Anything happens to the global warming, things can go wrong. Bamboo will not die. Bamboo will survive through any sort of climatic condition. But we never developed what technology to, how do we use it? How do we improve the yield? How do we tame it? It's like wild. It's wild in the forest. We need to tame it through agriculture. That's how we did it with the rice. That's how we did it with the sugar cane. Sugar cane was not a crop like this 1,000 years back. Take example, sugar cane in India. It was only in Orissa, I think in Aska is the first sugar factory which came up in, if I'm right, 1827. And then it started into many sugar factories. Today we have 550 to 600 sugar factories, because of which in the last 150 years, sugarcane has become a commercial crop. Bamboo also is going to be a commercial crop, 3, 4, 5, 10 times more than the sugarcane. Because sugarcane gives only 3 products, bamboo gives you thousands of products. Yes, bamboo can give you, it can switch over energy to replace a coal. Orissa is full of coal. They're using a lot of coal to burn and increase the carbon dioxide. Your atmosphere has got large quantity of carbon dioxide, less of oxygen. That can get replaced with the bamboo. Bio-CNG gas can be produced with the bamboo. With the shell we are working, we are able to convert into petrol and diesel. And similarly, electricity. 1 kilo bamboo can produce 1 kilowatt current. 1 ton can produce 1 megawatt electricity. So 1 acre can produce 40 tons, 40 megawatt of electricity. Similarly, ethanol. This is another biotechnology role. Bamboo has got highest cellulose content. 65% cellulose is available in a quantity of 40 tons per acre, which can be digested into ethanol, which means 4 kilo bamboo can produce 1.2 liter ethanol. 1 acre can produce 12,000 liter ethanol per acre per year. Prime Minister, our Honorable Prime Minister, Mr. Modi, 10 days back he spoke, he said we should increase to 20% blending of ethanol in our fuel. Huge. Today we have ethanol only from sugarcane, which is able to satisfy just 3%. Bamboo can do much more beyond that. Why? Because 1 acre of bamboo is giving you 12,000 liter. Sugarcane gives you only 450 liter per acre per year. Yeah. So I just looked at what is the area needed if you want to replace all these with this kind of a bamboo to produce this fossil fuel. Not now, maybe another 10, 20, 30, 40 years. It is 136 million ton of bamboo you need for bio-CNG, 196 million ton for ethanol, 350 million tons for electricity, 800 million ton for petrol and diesel, and 900 million tons for coal. All put together, it's 2,400 million tons. In terms of area, it is going to be 600 lakh acres. So the bamboo is going to be grown like a commercial crop for which tissue culture, agriculture is very, very essential. It so happened I did all this combination of study 40 years back without knowing this. Today, you all be with this. Mr. Murthy sir is here. He is in our bamboo group and bamboo society and taking that knowledge of bamboo to all the institutions, including yours. And what is happening is a revolution because of these two. There are bamboo, they're available so many years, but nothing has happened. But this to change, tissue culture and agriculture could increase the yield. That becomes a huge opportunity for the bamboo. What it can make toothpick. It can make keyboard and mouse. It can make cycle. It can make even wind blade, longest structure. This is a Madrid airport roof completely made with the bamboo. Forget about Madrid airport in Italy. Now you come to our own Bangalore Terminal 2 is much, much better than this, full of bamboo. 65 acre is the terminal size, completely packed with the bamboo.
Biotechnology, and who's actually also working.
Sorry, sir? Somebody said someone?
Yeah. No, sir, I think that is by mistake.
Desktop computer, the complete desktop computer, Dell computer is got this. IKEA in Hyderabad, they have this shop open and all these are bamboo-based product. Bamboo is making cotton. Once the bamboo is available, all these are possible. This cotton is there in China for the last 15 years. And this is the stage of process, again, biotechnology process involved, where digestion of this takes place, and then it is converted into yarn. And this technology is not available in India. I'm sure your institution can take it. Orissa is full of bamboo. It's only the right bamboos should be selected and done. This is Park Avenue pant and shirt. 13 years back, it's available in India. 13 years back, not now. All colors are there. Even today, it's available. Bamboo is converted into electricity. Yeah, 200 acres can make 1 megawatt every hour, 24 hours, 365 days. 8,000 megawatt hours can produce because 1 kg bamboo makes 1 kilowatt current at a price of 2.5 rupees, less than the solar panel. And carbon negative power. It's not carbon neutral like solar. It's not like wind, which is also carbon neutral. This is carbon negative because every ton of megawatt of power produced, you're also getting 100 kilograms charcoal. Similarly, bamboo is digestible, initially pre-treated, and it has got a cellulose. Cellulose is digested into starch. Starch is converted into sugar. Sugar is fermented with the help of microorganism into ethanol in a matter of 1 week's time. And our president at that time, Mukherjee went to Finland. Pranab Mukherjee went to Finland and signed the technology, and we got it, and we are doing it. Right now, we are using sugarcane as a technology to produce ethanol, 40 tons of sugarcane per acre, which is converted into 4 tons of sugar plus 100 tons of molasses comes out as a waste. This 100 ton molasses ferment, you're getting 400 liters of ethanol. Now, US does not have this kind of a sugar cane. They have starch from corn and wheat and rice and potatoes. That starch is converted into sugar with the help of enzymes, and then it's fermented. Then you're getting ethanol. In India, starch is a food for us, for the animal, for the bird, for the chicken. So we cannot really divert that. Instead, bamboo is non-food material. It's got a cellulose, convert into starch, starch into sugar, sugar into ethanol. This is science. You and me can develop the science and give it to somebody. What is important for the economy is, what is my yield? 500 liter per acre for highest yield is for sugarcane is 500 liter. For the maize, it's 3,000 liter. Bamboo, 10 to 12,000 liter per acre, for which you don't need to replant them at all. Maize, rice has to be replanted once in 2-3 years time. Once in a 2 to 3 times in a year. Sugarcane once in 2 years or 3 years at the maximum. But again, replanting is there. A lot of labor. Whereas here, it's such a permanent crop. And country like a state like Orissa is one of the place of origin for bamboo. Some of the species have come from there. And what are we doing? Nothing. Because lack of knowledge, the lack of planting material, lack of agriculture. Your university should take it up and do that. Now we have gone one step more, converting the gas into oil. That oil, after oil, also you are getting a charcoal as a byproduct, and the 25% of the biomass comes out as a oil, 25% comes out the biochar, 20% comes as a gas still, which can be used for heating purpose. Now, this same technology perfected by a shell company called Ih2 Technology, and that Ih2 technology is nothing but patented technology by Shell, and the biomass of bamboo is put into this along with other biomass. You can use it. Pyrolysis. If any engineering student attending, they'll be able to understand. This is called the pyrolysis, burning the material in the absence of oxygen. And at the temperature of 400 to 550 degrees centigrade, it releases the gas, a syngas, which is clean, and then all this charcoal is collected, the biochar, and the gas goes through a reactor, and the reactor is converted, adjusted with a chemical, either to produce petrol, gasoline, jet fuel, diesel, or kerosene, whatever you want, you'll be able to produce. And the fumes comes out, goes to a hydrogen plant, converted into hydrogen, put back again into the hydropyrolysis process. And this is the unit in Bangalore in a shell company. They have this 5-ton production capacity. What is commercially viable is 150 tons, but 5 ton is already operational. It is available. One can really go and see it. And this is the biogas, bio-CNG gas from bamboo in Pune. And this is a bamboo. This is a reactor. Is again a biotechnology process of highly efficient microorganisms are put into that. Within 1 day, it is converted into a gas of CNG gas, which has got something like sulfur dioxide, carbon monoxide, all are removed and then put into the cylinder. In the front, they have the bunk. This bunk is dispensing the gas to the auto rickshaws, for the cars, for the bus, for the vehicles. All this going on for the last 3 years. 3 years, yes. And today we are working on the hydrogen technology, because having produced CH4, it's a matter of removing the carbon from this to make the hydrogen. And these are all the facility. By the way, how long the talk is? For 1 hour or?
So we have time till 1 o'clock. You can exceed, sir.
Okay. If it is there, then I'll switch over to another small topic in biotechnology, where how do I reduce the cost of tissue culture lab? What is the student should look at it? Then I'll go to that. Yeah, I'll do that.
Please, thank you.
Yeah, thank you. What is affecting tissue culture not becoming successful? I know Mr. Rao also told in the beginning that, it's not successful. The successful is because of 2-3 reasons. One is failure rate is more. The second is the cost is more. Now, I'm going to talk to you on the cost. How do we reduce the cost? The cost could be reduced by putting the project in a proper location. The second, the capacity utilization. Every month, it should be able to deliver plan as per the requirement, or we should create the requirement and see that the lab is running on throughout the year with enough capacity. Then the capital cost is normally very high, should be brought down. Then the next is the design of the lab. The design of the lab, when I say, is the laminar flow chamber, the growth room, the flow of the material, and the using of electricity, all that. So efficiency operation. In the beginning, I told you I was doing around 120 plants. I was so proud. But today, my people are doing 4,000 plants production per day. So, and the same thing is going to happen here also. So, efficiency of operation is more important to reduce the labor. How do you do that? All that I'll tell one by one. Then the range of products. I spoke to you so many products, and the product should be able to really, bring some meaning to the people in agriculture. It should be able to increase the yield. It should demand creation. This is not me, my friend, but this is in 1992. Look at the lab. I was so thrilled, proud, because from agriculture into tissue culture, I see some plants are growing in the test tubes, bottles, not bottles, conical flasks. Thrilled. If we get a plant without the soil, it's highly thrilled. That's how it was there. But I never knew the reality at that time. Then when I went to the commercial company, I was asked to develop the lab. Then we did all these, the glass plate, test tubes with the tube lights, a little more perfect and all that. We thought we had done the best. Every time we feel that, always it is a human being tendency. So in later on, I was able to really do a little more better job in 1990, and which is a moving rack system. I saw it in the library. In the British Library in Chennai, when I went there, while reading the book, I could see all the books are put in a mobile rack system. Oh, then I copied that system, brought to the laboratory. Today, most of the labs are using it. But I was the first one to introduce in India in 1987, 88. And then comes the sunlight room, where the plants are grown without tube lights. Plants are grown vertically, no more horizontal growth. Normally we grow the plants horizontally, right? Now in 2000, I kept on working on this. I said, why do we need a light? Why? Light is not needed for the plant to grow, because we are giving all the starch, everything, sugar, everything is there in the media. So then we developed a technology called dark room technology. No tube light, no sunlight. In between, I also worked in LED lights. This is what the innovation is. What will happen when the plants are not there, lights are not there, they're going to be etiolated. They're going to grow tall. More gibberellic acid is going to be produced. And by adding anti-gibberellic acid, that growth also will not take place. So plant is good. There is no photosynthesis needed for which the light is provided. Now, so that's how we succeeded. Anyhow, coming back to the sunlight room, you need a light for the last two phases, shooting stage, rooting stage, but not for the multiplication of the whole 10 months, 20 months. You don't need that at all. Only for the last 2 months you need. Now, this is the vertical way of growing bamboo, which I developed almost 22, 23 years back. And these are the vertical racks, and the light is coming from the top. And this is the horizontal rack system, where only one layer can be kept. You see them, the top is not open, it is closed with a proper double layer glass to avoid any dust coming from there, but allows only the visible light. No IR, no UV light into the room. And the plants are kept 1, 2, 3, 4, 5 layers, one above the other. And each rack has got 1, 2, 3 layers. All these are my own design. I told you in the beginning that I'm more of an engineer when it comes to laboratory. Now, university like you've got engineering also, agriculture also. If you all join together, I'm sure you will make much more bigger, better breakthrough than what I've done. This is with little my common sense. I used it, and you see them. It brought down the price. The capital cost is brought down. Sunlight room is 27 paise electrical cost, whereas electrical room is 53 paise per plant. Capital cost is also reduced, and we went for the plastic box, which I shown you. The top cap and bottom are same size, and it's openable, and you can also stack one above the other. I made a design in the bottom because I made the injection molding machine mold myself. So everything provision I kept in this, so you can stack it easily by stacking the boxes. You see them 1, 2, 3, 4 layer, 5 layers you can keep it, and whereas bottle you can keep only 3 layers. My capacity in the laboratory, instead of 10 million, it has become easily, it is jumped to 17, 18 million plants. So when you make 3 layers, it's less number of plants. When you make 5 layers, it's more number of plants. But this is not possible with the conventional laboratory, what you have now. Like this. One single layer, either bottle or box, all are same, because light is coming to the top. This is where the common sense differs. The plant can be, if you give the light from the sides, you can keep on increasing the height. Number of, you can also, if I keep then one more box here, automatically the shade of the first box is going to fall on the second box. The plant is not going to grow. The first box height is different. The second plant height is going, the growth is going to be different. So when you use this sunlight room along with the plastic box, the 53 paise per plant has come to 13 paise. My capital cost remains same. Production is increased. 8 paise is reduced to 3 paise now. This is how we should look at every bit of that is cost. Reduce the cost, capital cost, reduce the operation cost. This is the growth room with all these moving system, everything. On the left hand side, on the right hand side, you see them a duct. My last room is an air-conditioned room, which produces the cool air. It comes through all the way in the room and then get diverted, then runs through the room rack like this, for which we normally, everyone uses a metal duct. Metal duct. I do not know what is inside, but I can't go clean it, and expensive. What I did, I said, should we have this at all? This is a Blue Star company made this, but I converted with a polythene tube. And not only one side, the entire length of the room. You see them, the complete length. It's like a balloon. And now I could see what is inside. Is it clean or not clean? Whether rat is sitting inside or any dust is there, I can use and throw. I can just take it out and send it out. Now, what is important is functional and the cost. Cost is very, very important. This is costing me 1,90,000 rupees for 4 growth room. This is costing me only 30,000 rupees because few kilogram of plastic, 1 kilo of plastic is only hardly around 150 rupees. That's the difference. And it's only 7% cost. Like this, we can keep on talking. This is a laminar flow chamber. I'm sure you're all using it in your research. This is how I graduated myself and I studied and I also worked in several companies like this. But when I started Growmore 25 years back, I said, can I make these people to talk and work in the laminar chamber? Unknowingly, all these people are girls. And Indian girls, they're a little more talkative than the foreigners. Foreigners, they mind the job, they never talk. Whereas it's okay for them, or you have to put a mask. Now what I did, I made a chamber like this. A wall impressed chamber with a glass plate in the front. With the laminar, the same filter, Ih2 filter in the wall, 1, 2, 3, 4, 5 filter. I made 5% to sit there. Now they are happy, they're talking and working, my production has gone up. That's a fact. Socially, psychologically, also we should take care of people who are working. When I have 200 people working, naturally everybody is very important. Now, that has also resulted in reduction of my capital cost. This laminar flow chamber is costing in the market 2 lakh rupees. This laminar chamber I made myself for 60,000 rupees for 5 people to work. This is only 2% can work. And it occupies a lot of space. Here, no space. It is mounted into the wall. I pushed into the wall. This is made in Growmore by Bharati. This is made by Cleansites. I can keep on talking so many innovations. Like I'll come back to the greenhouse. In the greenhouse, you have polythene sheets and kept higher, cooler temperature by a pad called cell pad. This cell pad is a paper pad through which the water flows through that. When it is wet, when the other side the fan is working, the air is drawn through the paper, it becomes cool cell. Now it comes from the US. Now what I did, this paper, I replaced it with a tile, our regular roof tile. I put the multiple layer of tile, but only thing is I arranged in such a way that one is from the left, another is from the right with a gap. Then again right and left, so that water from the first tile falls on the second tile end. Then again travels back, falls on the third tile in the end. Again travels inside. So that is the way zigzag it is arranged, kept, and when the air is passing through this, after it is wet, the entire room becomes chill. Now, what is the advantage? Cell pad has to be replaced once in 2 years. Tiles remains for several years. No change at all. And at the time of making, your cost it is 2 lakh rupees for the entire greenhouse. If you are making with the bamboo tiles, it's only 28,000 rupees. And that too, you don't need a good tile. You need a third, fourth, fifth, or seventh grade tile, which is broken, or a cracked tiles is sufficient, because leak is better. More the leak, more the chillness, more the efficient. So look at the reduction in the cost, that reflects on the plant. Let me come back to the lab again. We have been growing plants in a tight, closed container with no air going inside, no bacteria goes inside, no fungus goes inside. Yes, that's very much needed. But in this bottle, what I did, over a period of time when I was working, I said, can I have a ventilated cap? This ventilated cap bottle, this is non-ventilated, normal bottle, like whatever you and me are using for large number of years. Now, the roots in media, the roots are not coming. They're struggling to come. The hormones are there because the gas inside makes all the difference. The moment you put a filter cap, they start producing a very broad leaf, and the leaves started functionally photosynthetically active, and the roots also come fast immediately because the leaf surface is more. I just turned the bottle to show you filter cap with the holes, and bottom has got a filter. Go to the net, it's available. 1 pound, almost 90 rupees one filter for one bottle. When you put 10 plants, it's 10 rupees per plant. You know, the technology is available. It's so expensive. I've been working on this technology. Today, we developed a filter for 30 paise, which could be used for 10 times. Now 30 paise, 10 times when you're using it, it's only 3 paise per usage, and you have 10 plants, it's not even 0.1 paise. Now this plant, when you take it to the hardening, this one is one from the ventilated cap, within 15 days it comes to this height. The regular plant takes a lot of time because the photosynthesis as well as hardening process is starting only in the greenhouse. There what happens, in the bottle itself, they start hardening like this. So this is the difference. Now that results in my cost reduction while hardening. I need not harden the plant for let's say like for 4 weeks. In 2 weeks is ready, because of which my cost is reducing. 82 paise is the cost of production. If I in the greenhouse, here is 1 rupee 42 paise per plant. The time taken is more. Naturally, my cost is more. It's like a rent I'm paying to the greenhouse. So this could be like that. Then again, the prunes of the banana which I shown you, in the banana, normally we all use net pot, which I also shown you in the beginning like this, net pot. But then net pot, a lot of people say, no, I don't want to use it. But then I started using a paper cup. You know, we all eating ice creams. We all eating cake. The cupcake, when you see that, there a paper cup is used. I said, oh my God, same thing, I can use it. I used the normal paper. I tried it, I failed. Because normal paper soaks in the water and they disintegrate in the bacteria within a matter of 15-20 days time. Idea is good, but doesn't work. But this keeps happening. You should not be a failure for all this. It's not a failure. Every time what you do when it's a mistake, it's a learning. Now, I never leave it like this. I keep on working. One day I was flying from Bangalore to Delhi in the Kingfisher at that time. They gave me for face wipe. Then I just wiped the face. I saw some paper wet for more than 6 months. Nothing has happened. And that's a paper that they gave me to me for wiping this. I wiped it. Instead of giving back to the hair hostess, It went into my coat pocket. Brought it back to the lab, checked up, it was doing good, and that's this paper. Then I looked for the paper, and that paper was available as embroidery for embroidering in the back. They are able to use it. Today, it's a lot of masks coming. So many things are there. I'm talking about 25 years back, and that paper we cut in the shape, put in the pro tray, and they are able to make the shape, and then they are able to grow like this. What is important is the cost again. 15 paise at that time. Today it's around 25 paise in net pot. Now it was only 3 paise. So the cost reduction and the biodegradability is brought in. So like this, I can keep on telling you quite a few things. Bamboo, tissue culture, biotechnology is full of hope for such kind of innovations, and innovation can bring down the cost, and innovation can, once the cost is brought down, you will be able to increase the product to use it in large scale. You can use even tomato to produce, you can produce even chilies or tulsis, or so many products can be made, provided the cost is affordable to the farmer. And that's one of the reasons why you integrate tissue culture with the engineering, tissue culture with agriculture, and then the sky is the limit. What happened? I just took up bamboo as one product after some time, 15 years. I've been working constantly onto this. Now, I'm not doing much work with the biotechnology in the lab, but that's because it's running. We have enough people, the managers are doing take care, but I'm looking at the product. How do we do it? How do we increase the yield? What is the spacing needed? The latest one, I'm working for Philippines to convert bamboo into a fodder crop. Yes. Normally, bamboo is planted only 160 plants per acre, which I increased to 500, which I now later on for energy, I increased to 1,000. Now we're going to put 3,000 plants per acre to grow fodder from bamboo leaf. It will be cut every once in 3 months to feed the cattle, because bamboo leaf has got 18% protein and excellent quantity of calcium, which is very essential for the animals. So thank you very much for the opportunity for me to talk to all the students. I hope the students and other people who are listening to this would have got some direction from this, and they will take it, use it for their career to come forward. Thank you very much. Now it's open to the questions, Doctor.
Thank you, sir. It was really mesmerizing to see starting from tissue culture and how cost has to be managed, and it is really helpful for all of us here. Before we go to questions and answers, I'll just request Murthy sir to give his address. Murthy sir.
Please open the video.
Sir, just a moment. Sir, you can unmute yourself.
Okay.
Yeah.
Can you all hear me?
Yes, sir.
Okay. First, let me profusely thank the encyclopedia, that is Dr. Bharati, and it is always a great enlightenment to listen to him. And I am very happy that all of you are so fortunate today to listen to him, to his innovation, to his wisdom, and untiring efforts in your field of biotechnology, agriculture, and also in engineering, I would say, because he has given his advice very nicely that you need to integrate the engineering part so that you conclude things in much wider way. So my profuse thanks to Dr. Bharati for helping all of you as a good friend. That's one. I have only one or two quick points to say in a minute or two. As you rightly said, the integration of engineering into the agriculture or tissue culture or biotechnology, one has to look at in the form the various other issues, various other developments coming up in the world, like as he said, ethanol and all that. Whereas there are several other things now coming up as the electric tractors, for example, and the focus on standalone power generation, where again this ethanol can play a very big role. You need to have power at your command instead of depending upon the grid. So because as an agriculturist, one should have power at his command to the extent possible. Even there is a problem in a main grid supply. So naturally, an electrical, now coming down on electrical tractors, people should know how does it work, what is a lithium-ion battery, and even in lithium-ion battery, there is a great possibility for a bamboo anode graphite. So there are several things where agriculture is getting its root into disruption. I think, as Dr. Bharati said. Then the other day I have seen a wonderful thing, a small farmer using a motorcycle for plowing. He has got a motorcycle and he puts the plow, connected it, and one guy holds the plow and other guy drives the motorcycle. So these are the things, innovations happening around, how the engineering can be, can be connected. You need to look around and be aware. And also things like packaging at the point of production. That's how I was associated with MS Swaminathan in the past. And it's called mobile agro packing, where you pack at the point of production by the farmer so that, he reduces the cost. The mantra what Dr. Bharati has been talking about. How do you reduce the cost to become more effective and efficient? So my only suggestion to this group, I am not going into the mechanical, electrical, electronics topics now, but I wanted to profusely thank Dr. Bharati primarily and appreciate sincerely your interest. And I'm sure you have recorded his wisdom words not to miss out by anybody. I'm sure you would have done it. So you can play it in your classroom, and so that's all, and all the very best to you. And thank you to be with you today. And as Dr. D.N. Rao also mentioned, it's a great opportunity, and your university has a great chance to get a world university ranking. I think which will take up that topic later on, because it is clean, it is green. Now you are talking of a focus on what Dr. Bharati said, added the color of bamboo focus. You are leading into getting into a disruptive technology as an agricultural expert. Thank you all.
Thank you so much, sir, for your nice words about the speaker as well as addressing to the other faculty members here. I would open this time now. This session is open for questions. Is any questions? Any questions? Please come forward.
Good to know there are 127 participants, or 150 participants. Great.
I think they have left for some classes or other commitments.
I think his lecture gives answers
Sir, I want to
simultaneously.
talk. Hello,
Yep.
sir.
Please introduce yourself and then.
Yeah, in a very short way.
Sir, I want to know that the development of the tissue culture technology and the natural environment, artificially we develop in the laboratory versus natural difference टा कौन सा? माने well equipment माने plant टा develop करे.
Could you just be more clear so that can you just repeat it once more?
You need to be more clear.
Sir, we develop the plant variety, hybrid variety in the plant laboratory, but we cannot develop the plant as the natural environment in the field. Why, sir?
We can develop the. He mean to say that we can produce many plants in the laboratory in vitro condition, but it doesn't happen in the field. Why it is? He's asking that.
Okay. So, laboratory is a process of speeding the rate of multiplication. The same thing can also happen in the field, but it is slow. For example, one banana tree can produce 10 suckers in a year comfortably. You can multiply them. But if you want to increase a number from 10 to 10 lakh plants a year, you need to have a process called tissue culture technology. I would put it this way. If you want matter to be copied, you can also retype the entire thing. But you can also do a Xerox copy of the entire thing. Tissue culture is like a copying the entire thing several times instead of retyping the entire thing. So both are same, both are going to give the same information. One is going to be faster, large scale. So that way, tissue culture is a process by which you are able to make more number of plants in the very short time, plus your errors are reduced. The mix-up is reduced. But disadvantage is the cost is increased. But the cost is able to justify its return. Normal plant, when you plant, you're getting in a banana 25 kilograms. Now, if you're doing tissue culture, you're going to spend 15 rupees more per plant. But then that's going to result with 40 kilograms of bunch. That means you're getting 15 kilograms additional. Even at 10 rupees realization, you're getting 150 rupees more per bunch, which is justifying the price of 15 rupees. Now, so the tissue culture is one of the latest process by which you're multiplying. Maybe what you're trying to ask is, since you're growing them in a tissue culture lab, which is air conditioned, which is very precisely done, will it work in a field? Yes, that's the reason why there is a stage called hardening in the greenhouse. All the plants, they pass through 2 to 6 months time of hardening, and then the plant goes to the field. For example, banana takes 3 months from the laboratory, 2 stages of hardening, primary hardening and secondary hardening. Primary hardening is the poly house where the humidity, temperature is partially controlled. Then it goes to a secondary hardening where it is nothing is controlled, it's open to the air. And then it is kept in the sunlight and it is given. In the case of bamboo, it takes 6 months to get hardened. So all these plants which have come through such a sophisticated process get hardened, and then they go to the field, because of which they're stable, they're good, they don't die. I hope
Yes,
I
sir. Yes, I understand.
Any other questions related to commercial aspects?
Hello, good afternoon, sir.
Good afternoon.
This is Dr. Satyarat Nanda, a faculty from Biotech Department, Central University. Yes, sir. So thank you so much for this excellent talk, sir. We are enlightened by your experience and your encouragement, sir. Sir, I have a small questions, like when we do commercial productions, tissue culture, how we control or mitigate the issue of somatic variations, sir?
Yes. Okay. There is a variation called somatic variation, which is arising out of the plant, which is possible when there is a change, either physiological change or genetic change. Somoclonal variations happens when the culture environment condition is not conducive to the plant, number one. Number two, when you pass through instead of tissue, if you go through a cell culture route, and cell is a much more unstable form, which they try to mutate, like how our virus is mutating today. Our COVID-19 is getting mutated. The cell is also trying to mutate. And that time you end up with a somoclonal variation. Now, this could be avoided by two means. One, you have a most appropriate media to grow with a lesser level of hormone. Number two, don't multiply them for too many cycles to grow. If you're multiplying only for 10 cycles, 7 cycles in the case of banana, the somoclonal variation is not going to come. Whereas if you're going to multiply them for 20 times, 40 times, 60 times, that means you're going to keep it for 2, 3, 4, 5 years. The cell is going to accumulate a lot of variations, and that will result in the somoclonal variation. So in a commercial setup, the plants are initiated, fresh plants are brought into the lab every 6 months or 3 months. And that batch is taken out. So no plant is multiplied more than 7 to 8 cycles. Then again, next batch, again, next batch, again, next batch. So lesser the number of cycle of propagation, and the somoclonal variation is less. Plus, the hormone, you can also multiply with a higher level of hormone, let's say BAP. You can also multiply 5 mg per liter which will give a very good fast rate of multiplication, 1:10, you will get it. But if you do that, the sum-of-normal variation will increase. Instead, bring it down to 1 milligram per liter, you will get only a ratio of 1:4 or 1:5. Commercially, anything above 1:3 is viable. 1:3 is more viable. You don't need to go really for 1:10 times, 1:20 times. So reduce a hormone whereby the plant cell does not go through stress. And by these methods, you can very well hold this genetic mutation. Today, what has happened? The government of India, the DBT, Department of Biotechnology, is insisting all the tissue culture lab to get certification. In the certification, you have to give a sample of plants to one of the laboratories, testing laboratories, where they do the genetic fidelity test. In a genetic fidelity test, they find out, is there any genetic mutation has taken place, any monoclonal variations come, all that they check. If the variation is there, that particular batch to be rejected. For every 10,000 plants, one sample should be given for testing. These testing centers are there throughout India and controlled by DBT through Biotech Consortium India Limited. And it's a wonderful system run. It's in the practice for last 15 years. And our lab was the first in 2007 itself got accredited. Today we are doing not only for monoclonal variation, we are also doing for virus testing. So these two are getting done. Many labs are doing it. I'm not the only person. Everybody is doing it. And this is a good system implemented by BCIL, Biotech Consortium India Limited, Delhi.
Thank you so much, sir. Thank you.
Welcome. Welcome, doctor.
Thank you, sir. Is there any other questions related to commercial aspects? Sir, I have one or two very small questions.
Yes, Dr. Pushpalata.
Sir, actually, I saw in all the photographs of bamboos that you are growing, we usually see bamboos are, I mean, almost when they grow, to certain level, they bend. They do not stand straight. But I see in your photographs that you are showing, they are all tall and also they're not bending. Have you given any support, or is it very strong to stand straight?
Yes, Dr. Mr. Murthy also is here. You know, I'll tell you, the species are broadly around, two different types. One is mushroom type of species, and another is erect species.
Okay, sir.
The photograph, whatever I'm showing you, is a mushroom type bamboo species, but next to that, there's another bamboo is there to support. Okay, but I do have a vertical bamboo, which will like a eucalyptus or a cashew nut tree or a ashoka tree. It will be vertical. It's called Pyrolysis oliveri. Code in the internet, it's available. It's a vertical bamboo. You can put it in the maiden in the road and they will not bend. And that bamboo is very special. Pyrolysis species is very special and they're very straight, don't bend anywhere. No mushrooming and all that, right? Now, that bamboo is used for pole wall jumping, fishing rod, or for making our walking stick, or for umbrella stick. Like this is a very special application called Pyrolysis oliveri. And that's a beautiful bamboo, vertical bamboo. Mine is not vertical, but because there is a bamboo when you cultivate, you're putting a lot of bamboo next to each other. They're self-supporting. But the last row is likely to bend like this. Whatever you said is right, is going to bend. And then the species difference also is there. There are some species partially bending, some are completely bending. But whatever the bending is, bamboo doesn't break.
Right.
Because you're from Orissa, you're likely to get hit by, at some time, a high wind velocity. And bamboo is the only tree which will bend against all the wind. It'll come back again. Coconut will break, tree will break, everything will break. Bamboo is the only thing, so because of which bamboo doesn't fall. In Japan, the kindergarten kids are taught, saying that if there is any natural calamity like earthquake, tsunami, high wind velocity, or cyclone, run towards bamboo. So that that's the only tree will not break.
Exactly.
Every tree at a higher speed, it will break. So what you asked me is the right thing. But whatever bamboo which I'm showing you, it's all arching bamboo. Because of the cultivation practice, it is not bending.
Right, sir. Thank you
Yes,
so
doctor.
Thank you so much, sir. And
Welcome.
one more question, very important question, I think, in the field of plant tissue culture. Contamination level, and what's the percentage of contamination that you are facing, or you faced, or you have any bitter experience because of contamination?
Yes, madam. Contamination is a very big subject. I can talk 3-4 hours on the subject, but to shorten that, I faced up to 40%. But my lab is running with 0.1%. The reason for contamination starts with the human being, air quality, and the method with which the autoclave is sterilized, and the tissue by itself, they carry the bacteria, fungus, deep-seated bacteria. Now, every subject has to be dealt separately and a separate method. And for example, human beings. Human beings are the main source, and they should be taught so clearly. They cannot just scratch their head and they take their hand inside. When you tell them to not wear a mask and do work, they will not do that. But they're not supposed to put the head inside. In the laminar flow chamber, when I put a glass in the front, is first thing to reduce my contamination. You know what happens? People, when they talk, people will put it slowly, the head will go into the chamber and the hair, something will fall down. Some small particle with the thousands of bacteria, it will fall. One sneeze of a person throws 3 million bacteria at a speed of 80 kilometers per hour. 80 kilometers per hour. So people should be aware that one sneeze is sufficient. All the entire row will get contaminated. Now, all these have been taken a lot of time to do it. Over and above all this, seasonal, outside raining, a lot of mold is there. Asparagus will come to the lab. So we have put a lot of filters for them. We have put positive air modules for this. And that positive air module is able to really push all the good air, filtered air into the room. Because of which, whenever somebody opens the door, no dirty air from outside gets into that, number one. Apart from this, even a painting is very important. I paint with the antifungal paint. Okay, more and above that, there is a fly which will come, it will jump everywhere, the tick and mite will come into the lab, and all of a sudden it will come, you won't know when it is coming, it will go through a cap, it will go through a cling film, it will go through a cotton plug, it will go contaminate, come out. And your building construction should be different. And all the corners should be combed. Any dust particle is sufficient where they'll go sit and they eat the dust, and then they go to the test media, they contaminate, they come out. Without any opening, it will do the job. So now what we do, every 15 days, I keep on spraying miticide in the lab. Then we also fumigate the lab every once a week. And also I take up pictures of the bacterial colony, fungal colony by opening a plate with a culture plate with a media, open it for 5 minutes, keep it and close it, just check it. That is routine. Like this, I can keep on talking hours together. And operators, you should tell them to wash, clean, take bath and come, especially girls. Bringing that culture is very difficult. I gone to the stage, I've been in this field for 40 years. Sometimes I used to give a comb to them, comb it and remove one or two hair which is stuck to this thing, put it in a plate, show the bacteria, fungus, put it in the notice board. That one person will do. Everybody next day will be washing come out. So it's a big topic by itself, madam. But you're right. Very, very important thing is contamination control is very important. Otherwise, our cost will be double, triple.
Right, sir. Very well said, sir, with live examples. And it was also one of the question of one of our faculty here, he has mentioned. And there is Dr. Vishwanath. He is asking one more question. I think this would be the last question.
Yes.
Phenolic exudation is the major problem in tissue culture. How you are managing? And one more question. I think direct shoot regeneration or somatic embryogenesis. Which one is better? He's asking.
What is the first question? Did you ask me?
Phenolic exudation is
phenolic exudation. I got it.
Yes.
Phenolic exudation is a reaction of the plant to injury. And once they get adjusted to the cultural environment, they don't exudate. I had this difficulties more with the mango, coconut, and initially with the banana. Now, what is phenolic exudation? Basically, they exudate the phenols. They start reacting with the oxygen. They become quinol. The quinol is able to produce a black color substance. They kill the tissue. Now, in the beginning, there are several ways of tackling this phenolic exudation. One is when you take the tissue, don't expose them to the oxygen at any time. Wash it in a water which has got a citric acid and ascorbic acid, and the media also should have it. Or have a media with a charcoal in it so that they let the tissue get stabilized in the first few cycles, and then after that the exudation will stop. It's like an injury response to the injury by the plant. Now, either you can wash it thoroughly so many times, or put in a liquid media, keep transferring every time, or in a solid media, every once in a week you should keep transferring them whenever you see the exudations. And exudation is the color, because original exudation is colorless. Once they oxidize, they are able to do that. So antioxidant is one of the good route. Less light, no light is better for oxidation not to take place. And washing is another method, or frequent transfer. Instead of waiting for 4 weeks to transfer, every once week or every 3 days once also transfer it. And once they stabilize, leave it for one cycle of 2 weeks, 3 weeks, 4 weeks, nothing happens. So that is a way to tackle the exudation. And the next one was
it is direct shoot regeneration or somatic embryogenesis, which is better?
Okay. So both has got advantage and disadvantages. Shoot regeneration, there is no genetic variability or somatic variation. Somatic embryogenesis has got genetic variability. Some of the trees does not make any difference. Eucalyptus, nobody is going to look at what is the somatic variation is going to be there. One can use a somatic embryogenesis. But the cost of somatic embryogenesis plants are, very, very cheap, very low. It could be even, 1/3 of the original plant by tissue culture. But direct shoot generation is costly, time taken. It takes, for example, in bamboo, if you do somatic embryogenesis, I can finish the entire process within 9 months to 10 months. But if you go through a shoot generation, I need 21 months. So that longer the time, more the cost. But guarantee is 100% in a shoot regeneration direct, but not in a somatic embryogenesis. But the same somatic embryogenesis can be used if you want to create a variability. I want to have a high yield. I want to have a mutant of different character. Then you go through a somatic embryogenesis, create the mutant, and then you regenerate the plant and check for the variations, whether they are suitable or not. So both has got its own advantage and disadvantage. What I'm using is only shoot generation, not the somatic embryogenesis.
Good afternoon, sir. This is Dr. Kaustubh Panda from the Department of Plant Biotechnology, School of Agriculture. Sir, actually I have a question regarding the challenges that you have encountered right since the start of your journey till the journey you have traversed so far.
Oh my God. It's a lot.
Big question he has asked. You have narrated a lot about it, sir. He is there.
Yes.
I know, but then I will make it short, or I'll make it something which is not known. See, I'll tell you the major thing is, number one, you need to get a protocol. Number two is you need to have money to start a lab. Number three, you need a market to sell the plant. Where to sell, who is going to buy it. And number four, making a team is very important. All these are possible with giving money, taking money, all that is possible, but your own team to work. Today, I'm sitting and talking to you, but by now, from the morning, there's almost 50,000 production plants are over with no error. That means I have enough managers, supervisors, workers, and the supporting staff. And that is working without my supervision, without my intervention. So this is a team. So man is needed, the team is needed. Very, very important. The success comes from the team. Then comes the market. So you have to search for the product. 40 years I spent to find a product called bamboo. And when it took the bamboo, there is no market at all. Believe me, 15 years back, zero market. But today, my demand is huge. I am the largest person in the world now. But with all that is small quantity only, because whatever you produce is not sufficient. So you need to look at the market. You need to have a right technology, cost control. cost. I reduce cost. Even today, I reduce cost, not for the salary, not for the employee welfare, but for the usage of chemical, structure, electricity. Why should I give unnecessary to power? 10 lakh rupees brought down to 1 lakh rupee today. That is kind of a challenges which I had. I kept on working. Almost I spent 40 years. I translated my experience.
Thank you so much, sir, for your patience, time.
Yeah.
I think now it's a time to thank sir. And anyway, sir, about this and after this, maybe we'll be in touch with you. And under your mentorship, there will be many more people who will learn this aspect, how to control contamination, how to reduce the cost, and how to manage the protocols, how you will be able to replace from high cost sterilization methods to low cost, and everything will learn. I think there is a long way to go beyond this. So there's a very small initiation that I have taken to after inviting you to this through this webinar, addressing all our faculty members. So I would request Dr. Kaustup Kumar Panda now to give vote of thanks to sir.
Well, sir, I thank you on behalf of all the members from the Department of Plant Biotechnology. I thank you profusely for sharing your rich treasure of experiences, as well as for accepting our invitation in spite of a busy schedule to deliver such an insightful talk. Well, before I would just like to emphasize on or highlight on a few key points or takeaway points, okay, of this webinar, which sir has delivered for a couple of minutes. Okay, sir has actually emphasized on the in vitro cultivation of a good number of agronomically, horticulturally, as well as medicinally important plants, as well as even sir has emphasized on the cultivation of a good number of recalcitrant plants under in vitro conditions, which are very difficult to raise under natural conditions. And well, sir, I would also thank you profusely for taking all the initiative for the conservation of bamboo, because most of the species of bamboo has been disappearing due to the depletion of forest cover. I hope it is you who has been taking all the initiative towards the conservation of bamboo. Otherwise, I hope the future generations would not have the opportunity to see this plant anymore in the wild environment. And above all, sir, the cost-effective as well as the economic approaches that you've emphasized upon to to carry out the process, to carry out this approach or carry out this process effectively is one of the remarkable points that needs to be carried as a take-home message from this webinar. And once again, I thank you profusely for delivering such an insightful talk. And I would also take the opportunity to thank Dr. KPN Murthy sir for his presence, which has added an ambience to the webinar. And the remarkable points which he had said, the key points, though he has spoken a very few points, but it was very remarkable, and really we got to learn many points or many things out of that. I would thank our Vice President, sir, Dr. D.N. Murthy, Dr. D.N. Rao, sir, for creating such an ecosystem wherein we get to interact with a good number of eminent personalities who have really contributed meaningfully to the sphere of science. Sir keeps on, sir just chases all of us, okay, to conduct webinars, to conduct workshops, to be a part of training programs. Really, we do learn a lot from all these activities, from all these events. So I thank you from the core of my heart, sir. Then the Dean of School of Agriculture, MS Swaminathan School of Agriculture, Dr. S.P. Nanda, sir, has been very instrumental in conducting all these webinars and conducting all these seminars and he keeps on asking every now and then to organize such events for our betterment, for the betterment of the faculty, for the betterment of the students. And the departmental head, Dr. Puspalata Ganesh, deserves a lot of applause and praise for taking the initiative for organizing such a webinar. And the crew members of the Department of Biotechnology also have contributed meaningfully towards the conduction as well as success of this event. And lastly, where there is no audience, where there are no speakers, okay, the event doesn't become a success. So I would profusely thank all the members who have taken an active part in joining this webinar and making it a rich success. A lot of thanks to you, sir, for sparing your valuable time. Thank you all once again.
So thank you, Dr. Karthik Panda.
Welcome.
Very much, sir. We'll be in touch, and under your mentorship, we have to grow. Under this plant tissue culture unit, especially in Centurion University, would grow under your mentorship. And thank you very much, KP Muthi, sir, for all your presence and making this very memorable. Thank you very much, sir. Thank you, everybody who are all present here once again. Thank you all. Thank you so much.
Thank you. Thank you, Moti ji. Thank you.
Thank you, sir. Thank you so much.